All right, hello everyone. This is the fifth time I've tried to record this lecture because about halfway or a quarter of the way through, my dogs keep interrupting me. So hopefully this one gets it right, and I don't have to try to record it again because that would be pretty sweet. So today we're going to be talking about, can you put a price tag on an ecosystem? Can you evaluate how much an ecosystem's worth? And I think this forms a foundation for many of what we're going to be talking about later in the course in terms of how sustainability can be profitable, how you can turn a return on investment on sustainable practices, and how you can make sustainability something that's part of every sort of economy on the planet as a whole. So again, I see this sort of as a foundational topic. So um, I like to start off with this comic when I talk about this, and we have this old guy with his glasses and his super duper thick mustache and his big long nose saying, as you go through life, take time to monetize the roses. And this really sort of puts into perspective what we're talking about today, because you have someone that's putting a price tag on nature, because whether you think it or not, nature has some extrinsic value, whether it's to investors, whether it's to people, whether it's to just anyone, businesses, anyone alike can put a value on nature for a variety of different reasons. And we're going to talk about how we put those ecosystem services with a dollar sign. So what's an ecosystem? We mentioned this last class, but it's all the living things. So this is what we call the biotic components, interacting with the non-living things, which we would call the abiotic components. And this is all within the same area. And when we're thinking about what a biotic component is, this is comprised of herbivores, so plant eaters, detritivores, which eat dead things, carnivores, which are, I'm sure you guys all know this, but they're hunters, so they're eating flesh typically, but they can also be what we call omnivores, so eating flesh and plant matter. And then finally, we have our primary producers, which are going to be our plants, our algae, our bacteria, things like that. So that's the living part. That's the biotic part. Our abiotic components are things that you might not really consider to be part of nature, just they sort of are the environment, right? So sunlight, temperature, water, nutrients, wind, pH, anything you can really think of that's not living, that's part of an ecosystem. It could be even physical structures like a mountain. Those are all abiotic. And ecosystems are dynamic. They change through space, they change through time, and the ecosystem is in constant interaction between both the biotic components as well as the abiotic components as well. Um, and overall, when we're thinking about an ecosystem, we have what are called ecosystem processes, and these are both biological, physical, and chemical activities or events that link organisms with their environment. So you can think of sort of just a basic example of this. If you've ever been to the Cape, you might have seen seagrass. So it's just this grass that grows underwater. What seagrasses do really well is they pull nutrients out of the water and they store it inside their roots. And so that's an interaction between nutrients and a primary producer. So taking that nutrients out of the water, putting it in the roots. So that's interaction between biotic and abiotic. And what these ecosystem processes do, and not just storing nutrients, but any other process you could think of, they contribute and help maintain what's called ecosystem integrity. Now, ecosystem integrity is simply just referring to is the services your ecosystem provides intact? And we're going to talk about many of these ecosystem services in just a moment. But before we move on, I just wanted to make note of this really interesting concept in biology that we observe. And so we talked briefly about biodiversity last class. And remember, biodiversity is just simply how many different living things you have in a given area, or maybe even the planet as a whole. And we have what's called ecosystem functioning. So again, it's the same thing as ecosystem integrity, just how the ecosystem is doing what it's doing. Now, this is sort of interesting factor that we notice in nature is that when you have more biodiversity, ecosystems function better. And the way this works is if you have more diversity, you have more traits. And when you have more traits, well, that means your communities are less likely to respond to change in response to a disturbance. And then if you have more traits, communities are also likely to bounce back faster after disturbance. So put it this way. If I have a community that's hit with a hurricane, the community that has more biological diversity, more traits, is less likely to change in response to that hurricane and is likely to bounce back faster in the event that it does change in response to the hurricane. And just to show you another example of this, this is a classic example from aquatic ecosystem ecology, where we look at the nutrient removal efficacy of plankton. So we have one plankton community here and a multi-species plankton community here. And as you can see by this, the size of the arrow, which is referring to how much nutrients they are removing from an ecosystem, you see that the low diversity plankton removes less nutrients than the high diversity plankton. And this is not something we just observe in plankton. This is something we've observed across many, many different facets of biological ecosystems. It's kind of a really interesting factor. And I think, just sort of keeping this in the back of your mind as we go forward with this class and we talk about ecosystem services and we talk about value. Now, humans, as with everything, and as we talked about last class, the Anthropocene is a really hard, essentially, pressure on the planet. And human activities, as you can imagine, have combined to influence ecosystem processes. And so we do this via a number of routes. So we'll just talk about a few of them. There's many other routes as well, but these are the most common 6 that we like to think about. So we have overfishing, taking too much fish, or sometimes taking too much incidental fish from the ocean. Nutrient pollution via septic tanks, wastewater. You could also think of pollution generally as like, chemicals, oil spills, things like that. Species introduction, so introducing species to an area that they never existed before. So here in Massachusetts, we have a bunch of those. We have grasses, we have plants, we have the Asian longhorn beetle. We have all sorts of crazy things here in Massachusetts that are species introductions. Climate change, which you're going to talk about pretty in depth later in the class, but again, changing or warming of the Earth's climate as a whole. Sedimentation, changing how rivers flow, dams, things like that. And then finally, deforestation, and I think this one's pretty easy to understand. You cut down a forest, you change how that ecosystem is going to function. But all these impact ecosystems in a variety of different ways. And again, they are all human-induced. Now, do some of these things happen naturally? Yes. You can see, species introductions and changes in sedimentation and deforestation naturally happening, but the rate at which it's happening is where humans come in. So, but ecosystem services are where we put a value on, and so nothing has an intrinsic value. It has to have some sort of value or perceived value to humans, right? We don't look at a beautiful forest and say that's valuable to me just because it's a forest. We look at that forest and say, well, that forest is valuable to me because I can take timber from it. I can go hiking in it, right? It has some perceived value to humans. And these are all tied to what we call ecosystem services. So these are benefits that humans derive directly or indirectly from ecosystem processes. And so this has been these ecosystem services have been broken up into 4 major categories in 2005 by the Millennial Ecosystem Assessment through the United Nations. And one of the sort of the sad things that came from this 2005 assessment was that 60% of all ecosystem services across the planet are being degraded. And the 4 categories they really focused on and really clearly defined, which we're going to focus on for the remainder of this lecture, are going to be provisioning services, regulating services, cultural services, and support services. And if you want to take a peek at that sort of their report, it's going to be down here at the bottom. We're going to walk through all these different types of services and the examples of them as well. So don't fret, you don't have to read stuff from the UN if you don't want to. So we'll start off with the most obvious. This is going to be the provisioning services, things we physically take from the natural world. And these are direct marketable benefits to humans in the form of raw materials and goods. And this is the most straightforward of all of them. You have water, food, timber, plant fiber, natural gas, oils, and medicines. These are things we directly take. Now, these have direct benefits, and they have varying levels of value, right? Things like medicines have a very high value. Things like timber and plant fiber have less value, right? And then there's some things that probably shouldn't have a value, right? Like water probably shouldn't be monetized, but it is. It's what, like 65% of all fresh water is monetized in some way, shape, or form, which is really, really sad when you think about how many people don't have access to fresh water, but I digress. So this is our provisioning services, all things we have a physical we can take from nature. And then the obvious other one that is here is that sort of is encompassed by these things is animal biomass as well, food. Next, we have regulating services. So these are processes that help sustain ecosystem health, and these help essentially maintain that category of ecosystem integrity. And these include things we don't really think about, but they include pollination, decomposition or recycling of nutrients within an ecosystem, water and air purification, erosion and flood control, carbon sequestration, and climate regulation. These are all things that ecosystems do naturally. Ecosystems rely on pollination to keep plants going. They rely on decomposition to bring new nutrients into the system. All these things ecosystems are doing naturally to keep themselves going. But Incidentally, they provide regulating services to humans. And one of the most valuable regulating services that ecosystems actually provide just by being themselves is actually erosion and flood control. Some of the most valuable land on the planet is those that control floods, because as we've seen from whether it was Hurricane Maria, a couple years ago, or maybe something really destructive like Hurricane Andrew in the 90s, flood control is a huge monetary value, right? Billions of dollars every year. So all these things are just things ecosystems naturally do to keep themselves going as a whole. Next up is cultural services, and this is our connection with nature. So these are non-material benefits that advances the development of people. And these include recreation, art, music, and architecture inspired by nature, spiritual sustenance, as well as what you guys are doing, science education. And sort of a thing that, it's strictly tied to how nice nature is, right? If you have a degraded or cut down forest, well, that forest is no longer providing you any cultural services. It's just a cut down forest, right? So you lose that value by deforesting. And this was actually partially introduced in E.O. Wilson's idea of biophilia. So this is his hypothesis that human intrinsic connection with nature. And the idea being is that humans have an intrinsic connection with nature because we came from nature, right? We like to think we're not from nature, but we came from nature at the end of the day. So we do have this overall connection, and we do experience it directly via our connection with nature and the benefits we get. Again, recreation, art, religion, science education. So these are all the things that we get just by nature being nature. So for instance, I like to take my dogs to the salt marsh. That's about a half hour up the road. I go there because I like the salt marsh. It's beautiful. My dogs like it because they get to get muddy. But again, it's something that nature is providing just by being nature. And then finally, we have our supporting services. These are necessary production of other ecosystem services. So all the ecosystem services we just talked about are built upon this idea of supporting services. These are natural processes that help sustain ecosystems. And without them, the other three would not exist. And these include photosynthesis, so taking carbon from the atmosphere and making sugars and plant biomass, recycling of nutrients, formation of soil, water cycling, and habitat formation. So all these things that are the processes of maintaining, creating new ecosystems, new habitats. This is what we consider our supporting services. And arguably, this one is at times can be very hard to quantify, right? It's kind of hard to quantify habitat formation or soil formation, or even something like nutrient cycling, but we certainly can quantify photosynthesis and water purification and stuff like that. So it certainly is a thing, but again, none of the other three services exist without our supporting services. So can we put a price tag on this, right? So we talked about these four services, right? Can we put a price tag on them? I've talked about directly how they can benefit us, right? We take lobster, we go to the salt marsh, right? We have all these things that we can do that have a value or a perceived value to us. Can we put a price tag on them? And you should know that because I'm not saying no, that the answer to this is yes. And so we could think about a hypothetical situation here. We have a coastal ecosystem here. You can pretend this is Massachusetts because this would be very much like on the Cape, right? We have a coastal community. We have farming. We have fishing. We have recreation. We have seagrass beds. We have um, wetlands to protect the coast from storm surge, right? So all those ecosystem services, those four ones we just talked about, are all present in this ecosystem. And whether or not they realize it, these ecosystem services have really high value to them. Now, the value typically from coastal ecosystems, right? In terms of humans, it's like real estate property on the water is very, very expensive, right? But there is that direct benefit of all the natural and wonderful things the ecosystem already provides for the coastal services. So we can put a price tag. That's the bottom line here. So the value of the world's ecosystem is actually immense. So in 1997, some people, and if you want to take a read at about sort of how this is calculated, take a peek down here at this. Some people, Costanza et al. In 1997, did put a value on the world's ecosystems. So they took all these ecosystem services, calculated dollar values, and came to the conclusion that in 1997 that the world's ecosystems were valued at $33 trillion, which is a lot of money. Trillion is a lot. Trillion's big. You guys know this. You guys know money better than I do. In 2011, that was revised as a figure to being about $125 trillion. $125 trillion is a ton of money, right? That's nowhere you cut it. That's tons of money. And I hope that that dollar figure really shows you how valuable they can be. But one of the interesting things about their evaluation is that all these evaluations were differ depending on where you went. So for instance, seagrass beds, we talked about those briefly. They were valued at about $19,000 per hectare. So a hectare is about 2.5 acres. Um, hectare is just a science term. Um, it's equal to 2.5 acres, so a pretty decent size of land. Wetlands were calculated about $15,000 per hectare. Something like an agricultural field is only calculated at about $2,000 per hectare. And then you can look at something like a forest. It's calculated at about $6,000 per hectare. And so things range from being not very valuable to pretty valuable. And with things like seagrasses and wetlands and even something like a floodplain is worth about $20,000 per hectare. So a floodplain being something that controls floodwaters. And so they provide a lot of value. And you can think of something like a floodplain, right? It's just a floodplain, right? It's not anything particularly exciting, but that value of protecting businesses and homes from flooding is very, very valuable. And it's sort of a interesting thing, right? Some ecosystems are more valuable than others, but every ecosystem has some sort of value. And so by calculating the worth, you can actually say, okay, if I restore this ecosystem, can you convince people to pay for it? Is there enough value? Can I get a high enough return on investment if I restore this ecosystem? So the idea being is if I have a seagrass bed, if I restore this seagrass bed, does the investment that the government put in or the private agency that put in, will they get enough return on investment? And $20,000 per hectare is a lot of. So the question is, can we quantify this to human well-being? Can we try to put a monetary value? Can we put a value on actually physically doing it? And can we do it to convince people to do it? And so one of the sort of the pushbacks we've seen is putting a monetary value on an ecosystem will lead to commodification. And that's pretty much how capitalism functions, right? If it has a value, then, then people are going to try to exploit it, right? That tragedy of the commons idea we discuss. Um, and so some people argue, so this paper from 2006 by Macaulay argued that something should not be for sale, something should not be monetized, and nature potentially could be one of them. Because people worry, because as we talked about the tragedy of the commons, if you commodify something, if you make it worth money, well, tragedy of the commons is likely to kick in and thus result in reduced biodiversity, reduced abundance of plants and animals. So that's in direct contrast to Costanza et al. In 2014, who says valuation is not the same as privatization or commodification. So bottom line here is when we think about scientists, there's two sides to the coin here. Some say it's a good idea, some say it's a bad idea. Um, um, but at the end of the day, nature has some sort of extrinsic value to it. And given the rapid pace at which we are degrading nature, potentially the best way to to sort of make nature be appreciated, to make nature be restored, to make nature preserved, is to put a value on it. And this is just a little handy little flow chart for putting a value on ecosystem services if you want to take a peek at it. But let's talk about a case where they actually tried to do this. So let's talk about the Florida Everglades. For those of you that have never heard of Florida Everglades, I've never been there personally, but as a scientist, I appreciate its immense beauty here. You can see this is a picture of the Florida Everglades. It's known as the River of Grass because it's comprised of sawgrass, mangroves, cypress swamp, and prairie. And basically, it's a giant river flowing through these wetlands. And it's absolutely beautiful, as you can see from this picture down here. And this wetland as a whole filters massive amounts of water, so giving clean water to the people of Florida, and provides huge amounts of carbon sequestration, so taking carbon dioxide from the atmosphere and sticking it in plant biomass. So big deal for climate change. And it has lots of wildlife, alligators, birds, manatees, things that you find nowhere else in the world, you find in the Florida Everglades. And then finally, it has this huge recreational, cultural, and scientific value. people love the Everglades. I'm sure you guys have seen, whether it's in a good or a bad portrayal, people fan boating on rivers of the Florida Everglades, and it's a big deal. People fish in it. People swim in it, people kayak in it. It has huge recreational value, and it's also of great scientific value. Scientists have been studying the Florida Everglades for decades now, so it's really valuable, not just for the people that live there, but for the people that live that come into the area for tourism and things like that. So one of the sort of the unfortunate things about the Florida Everglades is, and for those of you that know Florida, you'll notice that the Florida Everglades, which historically flowed from about the middle of Florida all the way down to, the Miami metro area, as well as other parts of the tip of Florida, flows right in the path of some pretty major cities, whether it's Orlando or Miami, as I mentioned. And you can imagine that if you have this sort of really large wetland and it's on this very valuable real estate, well, something bad is going to happen to that wetland. And that's exactly what happened. It was drained. The wetland as a whole was drained for about 70 years to create both agricultural and urban areas. And so this is what its historic flow looks like. And this is what its current flow looks like. You can see it's greatly diminished overall. It's been diverted to go out into both the Atlantic and the Gulf of Mexico, as opposed down mostly through the tip where it was going before. And so you can sort of see that it's dramatically changed. And this was all the way up until the 70s and 80s. But one of the interesting things went in place is in the 70s and 80s, you had the United States Coastal Area Protection Act went in place. And they essentially went from aggressively draining the Everglades to figuring out how to restore the Everglades, because not only are changing the flow of the Everglades was bad just because of, well, people can't go there for tourism, it was greatly affecting the economy of Florida. And I hope after sort of hearing about those 4 ecosystem services, they're going through your brain how changing the flow of this massive, massive ecosystem affected the valuation in the economy of Florida. So let's talk about this. So people are starting to understand the consequences of the development in the Gulf Florida Everglades. So for instance, there was a very a unique ecosystem in Florida, which is called the pine rockland. This is what it looks like. It's not very exciting, but it was unique to Florida. It's actually one of the most endangered ecosystems in Florida now because it was so heavily reliant on the flow of the Florida Everglades. And then in addition to sort of getting rid of habitats like this, it negatively affected all sorts of other surrounding habitats. Because if we just go back here, you can imagine if this was your historic water flow and this is your current water flow, well, you're not getting enough fresh water here and here and here. So that's going to dramatically change other habitats, and not just habitats along this sort of flow of this major ecosystem. In addition, there was direct effects on the economy. So Florida used to have a pretty vibrant bonefish and tarpon fishery. So this is what a bonefish looks like. Not very exciting fish, but tasty to eat. Which, as I'm sure you guys all know, fisheries are very valuable commodities. Fish is one of the more expensive proteins out there. So losing that is hundreds of millions, if not billions of dollars. And then we also saw the loss of another very valuable ecosystem, which is the seagrass beds, which if you've ever seen a seagrass bed, they're not very spectacular, but one of the things they do invite is the Florida manatee, which likes to graze on the grass, which is why Florida manatees are called the sea cows, because they like to graze on this seagrass. So just a fun fact. So we're seeing direct effects on ecosystems in the sort of the original path of the Florida Everglades, including the rocklands, but also ecosystems sort of out of the sort of the coastal areas, or even in the sort of in between areas between the coast and the original flow, just by changing the hydrology of this area. So as I mentioned, there was a pretty heavy concern over the loss of ecosystem services. And the key here was ecosystem restoration. And ecosystem restoration is a reactionary thing. I have a damaged ecosystem, I'm going to try to fix it. And so you're trying to fix the missteps of the past. This is a direct sort of contrast to preservation, which is trying to just maintain natural ecosystems, not letting them get degraded. And so in the 2000s, Congress enacted CERP, or the Comprehensive Everglades Restoration Plan, that they estimated would take about 50 years to complete. It's doing pretty good now. What they did is they estimated that this project would cost about $11.5 billion. And that's a lot of money, right? I mean, maybe not in the trillions that the United States economy works. Our military budget is what, $750 billion. So $11 billion isn't a lot of money in terms of a whole economy, but in terms of, putting money into nature, people saw that as a very expensive thing, like a very expensive thing, right? $11 billion for nature. People don't like to do that, right? They see that as dumping money into nothing, right? Where you could use that to say build schools or provide healthcare or whatever you want to think about. You could use $11 billion for. And so one of the other issues we often talk about when we think about restoration is, well, can you actually do it? Is that $11 billion investment going to return you a profit, right? Can you get a return on investment here, or is it even worth it? Can you actually restore it? Is the area too degraded? And so let's dive into the monetary value here. So we can look at SERP. We can look at so what are the ecosystem services that SERP was providing in the Everglades? So we had a couple big ones. So the first one was groundwater purification. And you see that was about $13 billion. That's the estimate for what they would get out the back end. Real estate at about $16 billion. Park visitation, $1.3 billion. Just the value of open spaces like parks and stuff like that, not like as in like state parks where you have to pay to do it. At $830 million, and then about $2.5 billion for commercial and recreational fishing alone, and then finally about $12 billion for wildlife habitat and hunting. So we look at the total value of that; it's $46 billion. And then if you think about, well, how much are they going to invest? Well, that investment was $11.5 billion, and then you calculate that ROI, which you guys probably know how to do. You divide one by the other, and you get a return on investment of 4.04. So for every dollar that they were investing in the Everglades to restore it, they were getting about $4 back, which is huge, right? Just what you're getting from clean drinking water is worth more than what you put in. And we don't really think about clean drinking water as a big deal here in the United States, but you can look at some places, maybe like Africa or poor regions, or even here in the United States, like Flint, Michigan, right? Clean drinking water is a huge deal for some people. So just the value alone of purifying groundwater for drinking and bathing and all that stuff was worth more than they put in. And so the take-home message from the Florida Everglades is that ecosystem valuation is complex, but the value of services is not. There's direct value, direct value of an ecosystem, whether it's purifying your water, whether it's recreation, whether it's fishery, but they are valuable. And we like to think that we're, sort of separated from ecosystems, but we are directly connected to our environment. So ecosystem services are things we could not live without. And our activities, whether it's climate change, whether it's pollution, are directly affecting our ecosystems, and they're directly affecting the value that we could take from these ecosystems and the value that we depend on. We all depend on clean water. We all depend on timber. We all depend on food. So we all depend on these things that we're actually, by doing what we do in terms of like trying to make as much money as we can, are actually destroying the things that we directly rely upon. And ecosystem valuation, which is clearly not a perfect science, may help prevent destruction of natural services. Now, that's if you have a good governmental body in place, if you have a government that values ecosystem services. But the reality of, unfortunately, of our current administration is they don't really value ecosystem services all that highly. They open up areas for drilling and they relax regulations on corporations. So that's something that's not putting a great value on ecosystems. But there is a direct value of ecosystems. And if we can keep thinking about dollar signs, then we can start thinking about restoring ecosystems as well as preserving ecosystems. But the ecosystem valuation, it depends on perspective. And this is it's sort of an intersection between the economy, the environment, and what individuals value, because there's clear economic values to protecting the environment. There's clear environmental values for protecting the environment. It's really dependent on the person involved. Do you value nature? Do you value the services that nature provides over services that, say, are like from an oil company, right? So how do you as an individual value ecosystems? And I think one of the things that's nice about younger generations, so you guys are all, Gen Z, you guys are all younger, you typically have a much higher value on nature than, say, my parents' generation, which didn't have a particularly high value on nature. So again, it is this intersection between you, how you view the economy and how you view nature. And so this leads us to our final question of the day. What is sustainability? And sustainability is simply this sort of interaction of the environment with human activities. And this is both, human wellness, our social activities, as well as the economy. And sustainability at the end of the day is trying to do things with the environment in mind. Can you develop an economy sustainably? Can you push an economy to be, very, very high usage to being more sustainable? Can you develop that real estate more sustainably? Keeping the environment in mind, keeping these ecosystem services in mind. Because remember, just because you cut down a forest, you don't just lose the recreation, you don't just lose the timber, you lose all the things that are associated with cutting down that forest. The same thing can be said with anything. You spill oil into the Gulf of Mexico. You're not just affecting the animals, you're affecting the whole ecosystem. And you're affecting all the things that ecosystem gives you. So that's going to be the end of our lecture for today. Pretty short one, but a pretty important one. So I hope you guys learned a little something today. Please let me know if you have any questions on this material. And I would be happy to answer any questions if you need any questions answered. And I hope you guys have a great, or actually had a great long weekend. And I hope you guys have a great rest of your day/week.